In this lesson, we're going to be beginning our unit on probability. Before we start talking about probability, there are a few definitions you need to be familiar with. The first one is the definition for an experiment. An experiment is an investigation or procedure with varying results. So for an example, and one of the types of examples we'll be looking at is the rolling of a dice or drawing cards. So like if you have a deck of cards, what kind of card are you going to draw out of those cards? Or sometimes with spinners, if you have a spinner with multiple numbers on it, what number would that spinner land on? So those are some experiments. When you do an experiment, you have something called an outcome. So an outcome is a possible result from the experiment. So when you spin a spinner, you have multiple outcomes. There are multiple spots where that spinner could land. Or when you roll a dice, the dice can land on multiple sides. So your outcome is the possible results that could happen. So for an example, if you were to roll the dice, it could possibly land on the number 4. Or the same thing with a spinner. If your spinner has different numbers on it, the spinner could possibly land on the number 4. We also have something called a sample space. So a sample space represents the set of all possible outcomes. So when you perform an experiment, you have one outcome once you've done that experiment. But a sample space is going to represent all of your possible outcomes. So anything that could possibly happen. So when you're rolling a dice, it could possibly land on the number 1, the number 2. It could land on 3, 4, 5, or the number 6. Those are all of our possible outcomes. And if you notice, I wrote that in, these are called brackets. So those brackets are very important when we're writing our sample space because this is showing it's a set of numbers. It's showing that all of these numbers go together. Then we have something called an event. An event is a certain desired outcome. For example, rolling an odd number. So when you have an experiment of rolling a dice, it's going to land on a number. But maybe when you roll that dice, you want it to land on just an odd number. So that's going to be an event. Or maybe when you spin that spinner, you want it to land on just the number 4. That would be the event. Then we have a favorable outcome. That is all possible outcomes of an event. So thinking of the event in the previous example where we wanted to roll an odd number. So when we have a dice, you have all of your possible outcomes are 1 through 6. But then when we have an event of rolling an odd, on that same dice, our possible outcomes of rolling an odd are just 1, 3, and 5. And again, it's a set, so we want to use those brackets. Now let's take a look at these vocabulary words a little bit more in depth and how that we can use them. So first we're going to talk about identifying an outcome. So looking at number 1, a letter from the word basketball is chosen at random, list the possible outcomes. So if we were to choose a letter from the word basketball, we could choose the letter B. We could choose the letter A. We could choose the letter S. We could choose the letter K. We could choose E. We could choose T. We could choose B, A, L, and L. So those are all of our possible outcomes when we choose a letter, because those are all of the letters in the word basketball. If we look at a little bit more in depth, a favorable outcome. So remember, a favorable outcome are all of the possible outcomes from an event. So if we're a little bit more specific, so not just choosing any letter, what would be our outcome of choosing the letter K? Well, it would just be K, because that's what we're choosing. All of our outcomes of not choosing the letter B. So if we're not choosing B, we could still choose A. We could still choose S. We could still choose K. We could still choose E. We could still choose T. We could still choose our second A. We can still choose L and our second L. We just don't want to choose the letter B. So those are all of our favorable outcomes, not choosing B. Then choosing a T or a L. So that means we can choose T, we can choose L, or we can choose our second L. D, choosing a vowel. So remember, our vowels are A, E, I, O, and U. So from the word basketball, our favorable outcomes for choosing a vowel would be A, E, and our second A. So remember, for all of these favorable outcomes, we are using all of our possible outcomes from the word basketball over here on the left. Now we can do the same thing with a spinner. So taking a look at the spinner over here on the left, we're going to use that to help us answer these questions. The spinner to the left is spun one time. List the possible outcomes. So if I spin it, it could land on the number 1. If I spin it, it could land on the number 2. It could land on the number 3. Like in the picture, it is landed on 3. It could land on the number 4. It could land on 5. It could land on 6. It could land on 7. It could land on the number 8. It could land on the number 9. It could land on 10. It could land on 11. And it could land on 12. Those are all of the possible outcomes of what it could land on when I spin it. More specifically, a favorable outcome. So looking at a more specific spin. What if I wanted to spin it and it land on an even number? So remember, even numbers are 2, 4, 6, 8. So our multiples of 2. So if we wanted it to land on an even number, it could land on 2. That's on our spinner and it's even. It could land on the number 4, also an even number on our spinner. It could land on 6. It could land on the number 8. 8 is even and it's on our spinner. It could land on the number 10. And it can land on the number 12. All of those are even numbers on our spinner. B, it wants to know the favorable outcome of spinning a number greater than 10. So looking at that spinner on the left, our number's greater than 10. 11 is greater than 10, and it's on our spinner. And 12 is greater than 10. So those are two favorable outcomes of spinning a number greater than 10. C, a favorable outcome, spinning a number that is at most 5. So the biggest it is 5. 1 is at most 5, so it's 5 or less. 2, 3, again, it's at most 5, and it's on our spinner. 4 and 5. All of those are at most 5, and they're all on our spinner. And then D, spinning a prime number. So again, we do need to remember what a prime number is. Remember, a prime number is a number that only 1 in itself will divide into. So taking a look at our spinner, 2 would be on our spinner and its prime number. 3, 5, 7, and 11. Those would all be favorable outcomes of spinning a prime number. Let's take a look at one more example of identifying outcomes. And for this one, we're going to look at the months of the year. A month of the year is chosen at random. List all of your possible outcomes. So if you're to choose a month, you could choose January. You could choose February, March. Again, we're just choosing a month out of the year. You could choose April, May. You could choose June. You could choose July, August. You could choose September. Again, we're just choosing a month out of the year. October. You could choose November. You could choose December. Those are all possible months out of the year that you could choose. From those choices, a favorable outcome of choosing a month that starts with an A. So from all of our possible outcomes, a month that starts with an A could be April. Another month that starts with an A could be August. Those are two favorable outcomes of choosing a month that starts with the letter A. Or choosing a month that starts with the letter J or S. Well, from our possible outcomes, a month that starts with J would be January or June or July. All are possible outcomes that start with a J. Or an S, September. Or we can have a favorable outcome of choosing a month with no more than 30 days. So we only want those months that have 30 days or less. Well, February has 30 days or less. April does. June only has 30 days. September and November all only have 30 days or less. So that's how we identify outcomes. Let's look at counting some outcomes. So we're going to go back to an example of a spinner. So the spinner below is spun once. How many possible outcomes are there? So we can see on this spinner, it's divided into different colors. So when I spin it, it could land like it is now on this green section. So there's one outcome. It could land over here on this yellow section. That's another possible outcome. It could land over here on this green section. That's another outcome. So each section represents a possible outcome. So we want to count how many sections we have total. So as we go around and number each section, we can see that there are 8 possible outcomes of when we spin the spinner. Now, looking at some specific favorable outcomes of events. First, we want to look at the outcome of spinning a green. So if we look at our different sections, we can see that we have 2 sections that are green. So the possibility of spinning a green is 2. The next one is the favorable outcome of spinning not a red. So this green is not a red. This blue is not a red. This yellow is not red. This blue is not red. This green is not red. This blue is not red. This next section is red, so we don't want to count it. We want not red. And this yellow is red. Or this yellow is not red. So there are 7 sections possible that are not red. Well, the next one, spinning a yellow or blue. This section here is yellow, and this one's yellow. And then this section is blue, and this section is blue. And then there's another blue. So there are 5 sections that are yellow or blue that are favorable when we spin. And then the last one, a favorable outcome of spinning a green or red. This section here is green, and this section is green, and this section is red. So there are 3, oh, I'm sorry, I read that one wrong. It's of spinning a green and a red. So C said spinning a yellow or blue. So we identified all the yellow and the blue. D says spinning a green and a red. So there are 0 possible outcomes for that one because we only have 1 arrow spinning. So it can only land on 1 color at a time. So you can't land on green and red at the same time. Let's take a look at another example of counting those possible outcomes. This time we have a bag that contains 50 lottery balls. And on those lottery balls are numbers from 1 to 50. A ball is chosen at random. How many possible outcomes are there? Well, just like in the previous example, there were 8 sections on the spinner, so there were 8 possible outcomes. Well, in this bag of lottery balls, there are 50 lottery balls. So there are 50 possible outcomes. So from those 50 possible outcomes, we want to look at our favorable outcomes of specific events. So choosing a number less than 14. So we want to think, remember, these lottery balls are numbered from 1 to 50. So we want to think of how many of those lottery balls are numbers less than 14. So the number 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 13. Because we don't want to include 14 because it's less than 14. So remember, we don't have a lottery ball with the number 0. Our problem on the left says they're numbered 1 to 50. And it's less than 14, so it's not equal to 14. So we have 13 of those. Then choosing a number divisible by 3. So we want to think of all of the numbers from 1 to 50, and then how many are divisible by 3. So it's probably a good idea to list all of our numbers from 1 to 50 so that we can then visualize which ones are divisible by 3. All right, so now that we have all our numbers, we want to go through and count which ones are divisible by 3. So we know 3, 6, 9, 12, 15, 18, 21, 24. And if you notice, it's counting by 3s each time. So then once we know all of our numbers that are divisible by 3, we can go through and count how many of those I highlighted. And there are 16 total that are divisible by 3. C, choosing a perfect square. So this one might be a little bit more difficult, and you probably won't see this one a lot because we haven't talked about perfect squares before. So this is something new. So a perfect square is a number that if you can think of a number you can multiply by itself to get that number. So like 4, over here from our list, 4 is a perfect square because 2 times 2 is 4. Another perfect square is 9 because 3 times 3 is 9. Another perfect square is 16 because 4 times 4 is 16. So again, this is a new concept that you're not going to see a lot. You're not going to see that on a quiz or a test because we haven't talked about perfect squares before. But if we went through that list, we would find that there are 7 perfect squares from our list over on the left. And then the last one is choosing a number that is odd and at least 21. So I'm going to change the color of my highlighter. And then we want to focus on that is at least 21 and that is odd. So when we're looking at, it's at least 21, so that's the smallest it is. So that's from here to 50. But we just want the odd ones. So 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, and 49. Because it's at least 21. So from 21 to 50, we're going to count those yellow highlighted ones. And there are 15 of those. So let's take a look at another way we can count outcomes. John's piggy bank contains 12 pennies, 9 nickels, 23 dimes, and 16 quarters. If John chooses one coin at random, how many possible outcomes are there? All of our possible outcomes are all of these added together. So we would want to add 12 plus 9 plus 23 plus 16. And that would tell us all of our possible outcomes. Then we can use those possible outcomes to answer all of our favorable outcomes. So I want you to pause the video and I want you to give number 6 a try on your own.